So from when we stop, so let's continue. So now we are talking about aliphatic compound. So aliphatic compound are strange thing. But firstly, let me write the structure of methane for you. Methane is a single bond compound, right? So this is their structure. You will feel everything. Hectane, you know that this is what CH4 is for, what? Methane, right? So that's methane, right? So now we are now in hexane, C2H6, right? So it will now be CCH. You will feel every H. We feel it. Hope you understand. So that's that. So that's how you'll be feeling it. I hope you understand. So that's it. Now let us form the alkanes also. I want us to form the alkanes. They have the what? General formula of CnH2n, right? Right? So they have CnH2n. So their first member, don't go and say n is equals to 1. Their first member is not starting from 1. Unlike methane, that their first member is starting from 1. In alkane, their own member is starting from what? From 2. I hope you understand. So it means in alkane, you are not starting from meth, because meth represents 1, while het represents 2 in organic chemistry. I hope you understand. So our first member is what? Starting from n is equals to 2. I hope you understand. So that's where we are going to start. So now let's substitute the value of 2. So it's now going to be C2, 2 times 2, that is 4. So that will be what? It's not 18, it is what? 18. You'll be using this suffix. You know that in alkane it ends with n, so you'll be putting it at the back, but here it is n, so you'll be putting n. Now we are going to propane. So substitute 3. So you will continue, like you'll be adding 1, just like the way we are doing alkane. So it now be what? C3H6. I hope you understand. So that one will now be what? Propane. Then C4, I don't need to calculate it again, because I've taught you the way you'll be substituting it. So it will now be what? Butane. I hope you understand. So that's it. This is how we do it. When you get to C5, you now start to use mathematics, just like the way we did that of alkane. I hope you understand. So we now be hexene. Let me use different color. C7H14. So EP. So that would be octane. So I think you see how simple it is. So there's no big D. There's no big D there. So non-name. Then C10H20. So that's decene. So no big deal here. Now let's go to how we can form that of alkyne. Okay, let me draw the structure for alkane. You know that the first member of alkane is what? Is 18. So what is the formula? C2H4, right? Now let's draw the structure. This is where some students become confused. You know that when I was drawing C2H6, how did I draw it? I draw it like this, right? The way you draw this, you will draw this one also, but there's something you must do. Now, if you remember, I told you that the alkane, they have what? They have double bond. I hope you understand. So they have what? Double bond. So we must input that double bond there. Let me now check it. So we will now input the double bond at this place. I hope you understand the logic. So you input the double bond between the carbon. I hope you understand the logic. So we now say H, 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 H. So how many H is it? 4. It means it is complete. Now you will ask me a question. Why didn't I fill this place? Why didn't I fill this carbon at the top here? So this is what the rule says. Whenever there is double bond, you must not fill what? 2 hydrogen. I hope you get the logic. Whenever you see what? 2 double bond, you must not what? Fill 2 hydrogen. Hadn't been there is no double bond here. Like this one, I would have filled the hydrogen on the top. But there is no what? There is double bond here. So that's why I don't fill the 2 here. So in alkane, I can do it 2 ways. It's either I write it this way or I write it like this. Please be attentive. It's either I write it like this. I hope you understand. I don't write anything here and I don't write anything here. But 2 hydrogen is not there. So if I write it this way, I'm correct. If I write it this way, I'm correct. So in questions like this, if I write 2 hydrogen on the same side, they are called cis structure. It is cis structure. But if I write hydrogen, let me redraw this structure. This is what I draw. This is what I draw here. You see how I draw it? And now draw. I don't write any hydrogen. I don't draw any hydrogen there. I don't draw anyone. So this structure is called trans. But cis is a structure when I write 2 hydrogen on the same side. Or it may not be hydrogen at times. It may be other compound or element. I hope you understand. So that's that. I'm just introducing you to organic chemistry. We have not entered organic chemistry yet. Now let's go to the ethyne. So ethyne also, the first member is starting from, so alkyne. We're talking about alkyne. So they have the general formula CnH2n minus 2. So they start from, their first member is starting from n is equals to 2. It is only alkane that are starting from n is equals to 1. So their own compound 2, inputs 2. So it's now going to be C2, H inputs 2. 2 times 2, 4. 4 minus 2, so that's 2. So this is their first compound. So the first name of their compound is ethyne. I hope you understand. They are what? Ethyne. So their second member will be what? Input 3 here. So it's now going to be what? C3. 2 times 3, 6. 6 minus 2, that is 4. So their second member is propyne. So you see how easier it is. We now go to C4, H, put 4. That's why I get C4. 2 times 4, that is 8. 8 minus 2, that is 6. So that's called butyne. Hope you understand. So it's very simple. So this is how you'll be doing it. Then C5, H8. So that will be called what? Pentyne. You will be using mathematics just like the way we did the previous one. 6, 6, H 10. So that will be what? Hexyne. C7, H 12. So that will be what? That will be heptyne. C8, H14. So that will be what? Octyne. Then we go to C9, H16. That will be nonine. Then C10, H18. So that will be what? Decyne. So this is how we do it. Hope you understand. So that's that we get it. Now let's draw the structure for alkyne also. The structure. So for alkyne, so their first member, ethyne. So let's draw ethyne, which is C2H2. So let's draw the structure. We have 2 compound. Now don't forget that their own structure or functional group also is what? Triple bond. So their own functional group is what? Triple bond. I hope you understand. So here, in between their carbon, I will write what? Triple bond. Then now there is also a rule for triple bond. Whenever you see triple bond, you must not fill what? 4 hydrogen atom. I hope you understand. So you must not what? Fill 4 hydrogen atom. So it means in this place I must not fill. In this place I must not fill. I must not fill anything at all. So I must not fill anything at all. So which space do you think is left? So it remains this place. So this is the shape of the ethyne. So this is how you draw ethyne. I hope you understand. So this is how you draw what? Ethyne. So I hope you understand the logic. So this is how we draw ethyne. Now let's go to their hybridization. Their hybridization. Now you should know something, that methane is the first member of alkane. Please take notes. Ethene is the first member of alkane. Ethyne is the first member of alkyne. I hope you understand. So alkane, it is what? sp3 hybridized. Just know that because we are just introducing. Alkane is sp2 hybridized. Alkyne is sp hybridized. So if they ask you what's the hybridization of alkane, it is what? sp3. What is the hybridization of alkane? It is sp2. What is the hybridization of alkyne? It is what? sp. So what is the shape of alkane? If they ask you what's the bond angle of alkane, the bond angle of alkane is 109.25 degree. Please take note of that. 109.25 degree. Let me use different color. 109.25 degree. So that's the bond angle for the alkane, that is sp3 hybridization. Then if they ask you what's the bond angle for ethene, it is what? 120 degree. If they ask you what's this hybridization for ethyne, that is what? 180 degree. If you look at this structure yourself, see how it looks like. It's like angle on a straight line. So that's why we said it is what? 180 degree. I hope you understand. So that's it. So let's continue what we are doing. Now let's go back to aliphatic compound. Aliphatic compound. Now because of our time, I need to stop this video here. So we'll continue in the next episode.